All right. Hello, everyone. My name is Marco. That's my avatar, if you saw it on Jeremy's talk. This is my nickname on GitHub. Maybe someone knows me. I'm mainly helping in open source, mainly in the doctrine stuff, but maybe you saw me also in the Symfony stuff. I work for a company called Rove, and I also work as a freelance software consultant. These are basically the guys that work with me. We're basically people in the Zen Framework 2 community. So I distributed Rotten Tomatoes and eggs. So if you want to throw them now. I won't allow that later. So we're awesome. We do great designs with Marquee. And for those who don't know it, this is the definition of awesome. Okay, there's no other thing to describe awesome. Okay, so I'm in the doctrine team. I work on the ORM, and I worked a lot on the proxy stuff in the ORM, so this is what the talk is about. How many here use the ORM? I mean, I guess everybody, since it's basically integrated in Symfony standard. I'm a Zen Framework 2 contributor. I mainly work on the dependency injection stuff on Zen Framework 2, but generally building Zen Framework and doctrine stuff together. You can find me on Twitter and on GitHub. This is my handle. And I currently work on a lot of projects. This is not an updated list, but you get the idea. I waste a lot of time. Why? Well, I'm having fun, and somebody actually contracted me. And this is the proxy pattern in PHP. All right, so how many here know what a proxy is? How many could describe what a proxy does? Okay, 2. That's cool. You can get out. I'm just kidding. So a proxy is just a class functioning between us and something that we want to reach. So it is something between us and something else. This is basically copy-pasted from Wikipedia, but that's the best way to describe it. It is something like that hides between us and what we're interacting with. So the idea is simple. I don't know how many here are following 4chan or stuff like that, but the idea is simple. You see the deer here, and actually, nope, it's Chuck Testa. Okay, so that is what a proxy is. You think you look at it, and you think you know it is that what you think it is, and that's not it. So, yeah, nice portrait. So the idea is simply that we have an object, and this object is a proxy, and this proxy implements an interface, and this interface is the same interface of the subject interface. So now we're going to call them proxy and subject. So the proxy can entirely replace this subject object through the list of substitution principle. So this is basic OOP, so I'm not just going to rehearse on very boring stuff. But basically we have an interface, and then we have a proxy, and we have a real subject. And that's it. We have 2 objects that look basically the same. So every time that a client consumes a real, or basically an interface like this, we can also simply say, okay, let's replace it with, so basically whenever a client consumes the real subject, okay, like this, so it is based on the interface and it consumes a real subject. Whenever that happens, we can basically just tell, instead use a proxy. So this is what happens. We threw out the blue brick and threw in the orange one. So that's the basic idea. So the best way to implement that, at least in PHP, because we are super, super lazy people, is that a proxy usually extends this real subject. And that's just an implementation detail. But basically this is it. So in most cases, a proxy, the orange box here, extends the blue box, the real subject. So, and again, this is just theoretical. In theory, you should use interfaces. I don't know how many program here against an interface and how many patch it up really quickly, but you should use interfaces. So what? Okay, this is just basics. This is very simple stuff, and we all should know it. What do proxies actually do? So proxies are a fine line between decorator and there's a fine line between actually decorator pattern and proxy, and I didn't actually find a real good definition. There are some explanations about what a proxy is in this book. There's more stuff in this book. There's more stuff in other books. And there's a lot of confusion about it on the internet. And that's because there's really this fine line. And you go to websites and somebody calls them this way, the other calls them the other way. So I just want to pick the definition from the Gang of Four, basically the type of proxies that they collected. And the idea is that we have a remote, and we have 4 main proxy types. So we have a remote proxy, which is basically an object that looks like something, and instead is something else on a different system, more precisely in a different address space. So it may be on another process, it may be in another object somewhere else, it may be on the other side of the planet. Okay, we don't know that. We have a virtual proxy, which is a concept related with lazy loading, and it basically is a container, an empty container with something that still has to be filled. So it helps us loading stuff lazily without wasting resources up front. We have a protection proxy, which is basically a firewall. And if you think about it in networking, a firewall is nothing else than a proxy. It is between you and the internet, or between you and some client, and it filters out stuff, and you don't even know that it is there, but when it is there, you notice it when it's broken. So it's always like that. So the idea is simply that we have an object that protects access to other objects. Then we have a smart reference, which is the more complex type of proxy, in my opinion, and this one basically allows us to execute something when something else happens. So it allows us to say, whenever you do this thing on this object, then also do that stuff. And that is useful for logging and other stuff. We're going to see that in detail after that. So what? I'm a software architect, okay? I have no idea what I'm doing so far. Let's go practical. Let's see what we can build with this stuff. So let's go with the remote proxy first, because it's the simplest one to explain. What we have is basically we have a real subject, the blue one here, and we have a subject proxy. And in the middle, we have internet. Okay, I'm just going to assume we have internet in the middle. That's the simplest way to handle it. What happens is that we have then, this is what we have in implementation detail. So we have the real subject, which is on a system somewhere. It may be some very old, crappy box which runs an old API, which uses SOAP or whatever horror you're using there. And you have this server there, which is your SOAP server, your RPC server, your whatever server it is. Maybe also RESTful. That's not really our problem now. And then we have an adapter, which is basically an HTTP client or something like that, or some socket, whatever. And then we have a proxy. And the proxy is basically a mirror copy of that one. Every time that you run something there, it runs there. And that's through these adapters. So let's build one, a very simple one. We have a tweet object. Is this readable for everybody here? Yeah, okay. So this tweet object is basically very simple. We have a data array in it. We construct this tweet with an array of data. And we have then a get text, which will basically give us the text of the tweet. So this is not really cool API. I'm just making up an example. But basically, the idea is that we have the data in our object. What we do is we want to be able to reference any tweet without having the data up front. So what we do is building a tweet proxy, which looks exactly like the tweet, except that we are rewriting some of its API. So we are removing the constructor and we're replacing it. So what we do is passing in a Twitter API object, the identifier of the tweet, and then we override the getText method so that the getText method will use the adapter. So what it is now, this now is basically an object which is not on our system. We don't have the data up front. We have the data on a different system, and every time that we want the text for the object, we basically go through the API to the other system and we ask for it. And this is basically the usage for it. So what we do is building, in the normal case, a tweet with an array of data. I like arrays. I work on Zen Framework too. So we build arrays of arrays of arrays of arrays. So in the case of the tweet proxy, we build an API object, which is your API of preference. I'm not going to nitpick on that, but and then you pass the API object, you pass it to the proxy and the tweet ID, and these IDs are made up, so there's no real tweet for those. And then you can basically use it exactly like the other object. So it is a mirror copy of what is on Twitter. You don't actually care about how the object looks on Twitter itself. It just is relevant in your local address space, how you want to make it look like. So there's some pros and some cons. I think Pribsh actually says simply avoid this stuff. There are some use cases for it. So again, proxies are magic, okay? So be careful when using them. First disclaimer. So this allows us to share objects across different systems. We can avoid any usage of local memory. We don't have the tweet locally. The tweet is a bad example because the tweet is 140 bytes, but, well, not UTF, but basically that's the concept. If you have a video, if you have a large image, then you may want it in a different system. You don't want to copy all the images from Flickr into your system, okay? You just reference the image and fetch the data whenever you need it. You can use it as an adapter for a different interface. You don't know how the tweet actually looks on Twitter. You don't know how the image is abstracted in persistence or in APIs on Flickr. You don't know how the video is stored on YouTube. You just care about how it looks in your system. And the problem is that it is quite complex to set up. And it also fails whenever something breaks on the adapter. So now you have a view somewhere, you have your tweet template, and you say tweet.getText or tweet.text, and suddenly it explodes because it says I can't use the HTTP client because of some failure. The internet went bad or Twitter failed. And now your code breaks in a point where you weren't expecting it to break. So very careful about this, but it helps a lot in abstracting APIs, and it makes some stuff simpler. And again, it also is very slow. It depends on how fast your access on the different address space is. Let's move on to another problem solved by proxies. The other problem solved by proxies is lazy loading. How many here coded lazy loading manually in their APIs? Okay, I think basically we all did it, maybe without knowing it. This is more like a pattern. It's not really just one type of implementation, but it is used for very large and very expensive objects, or if you're over-engineering it. The idea is that you avoid DB connections, file input-output, very large objects in memory, like, for example, trying to encrypt some data and store it encrypted, or computing a very complex hash, which may take 1, 2, 3 seconds by design. Okay, so what we do is basically trying to work around this. And again, this is more of a problem. It's not really just a problem of proxies. So this is how we used to code lazy loading in our APIs. So again, I saw not many hands raised, but how many people actually coded stuff like this, where you try to lazy load stuff manually? Okay, so this is very common. This is manually trying to load stuff when it is needed. So what we have here is just a customer object, and this customer object has a constructor with a DB object, which already is like, oh, seriously? We pass in an ID. It looks like a remote adapter. And then what we do is basically on every public method, we try to call this init. And then we have this initialization method, which will fill the object with data. So this is very ugly. So there's a lot of problems. So now we have instantiation logic mixed with the logic of our class. So we construct our user object, but we're not passing in the data. We are basically mixing up the logic of the DB stuff with the logic of our customer object. We have a dependency to the DB. Why does our customer object know about the database? What sense does that make? Our customer is just email data and stuff like that. We don't have need for the database connection. It is not really optimized because we're basically calling init every time, and we're introducing constant overhead. But basically, the idea is that if we want to optimize that flow, we start introducing more and more code, and it gets less and less readable, and it gets really, really ugly. It is harder to test. Now, if I want a customer object, I now need to pass in a DB connection mock. What? And for every method that I want to test, I need to first verify that the initialization method is called. Doesn't look like that cool. So what we came up is basically lazy loading via proxies. What we do is either implementing a virtual proxy, which is a wrapper around some hole. So it's basically an empty shell with a hole in it, and we still need to load the data, or a ghost object. A ghost object is what Doctrine does. So what we have is an object with all the properties which are basically not existing until we load it. Let's build a virtual proxy first. So what we do is we want to build a proxy for this. This is an image object, and basically the image is constructed with a path. Whenever we construct the image, we load the image from disk, where we open the resource with the path, and then we have a getSize method which will use this private or protected property and will basically allow us to interact with it. So what happens here is every time that I construct an object like this, the system will basically go and fetch the image from the drive, load it into memory, and then we have the getSize, which will act on all this giant big object that we loaded in memory. What we do is extending it. So what we do is trying to move away all the logic for lazy loading, and we're not doing it manually as we've seen before. We're doing just lazy loading here. So what we do is rewriting the constructor, and instead of storing the image in it, we just store the path. And then as soon as we call this getSize method, we initialize the object, and then we delegate execution to the wrapped object. So this wrapped object, this wrapped is basically initialized here in this init method if it wasn't initialized before. So we're not rewriting any of the logic. The logic is all encapsulated in this image object. The image virtual proxy is just dedicated to lazy loading. So we separated two problems very clearly, and we can test the image object singularly, and we can test the initialization logic singularly. So this is how we use it. What we do is basically creating a new image proxy with some path, creating another one with another path, creating another with another path, and we see that basically the memory usage is constant. We don't have any waste of memory. And as soon as we then call image getSize, we start loading stuff into memory. So now we have 4 megabytes because we're loading a very large image. And then if we call it another time on another object, we have 8 megabytes in memory, and also input-output operations. So the idea is basically that this is basically kicking in and is saving us a lot of problems, especially with resource management. So there's some pros and cons also here. Again, this is magic. again. You're introducing these proxies. So somebody looks at the object and thinks it's an image, and it may behave differently because of how you load this stuff. So it keeps the instantiation logic and the initialization logic separate from the logic of our object. So now our object can be tested singularly, and we can just think about this simple image object without worrying about everything that is related to lazy loading. We don't have the huge memory or performance impact that we would have with just the image object, and we don't have that much overhead because we're basically just calling an init method every time, and optimizing this can be done because we already have an object which is only dedicated to lazy loading. So we are not introducing more and more overhead. We're just dedicating the lazy loading stuff to that object, so we can focus on optimizing that if needed. It is quite easy to implement. Did anybody have any problems reading that code? It looks quite standard. It's not really complex. The problem is that it is not really good when you have like big chunks of data. So you have 20 images already loaded somehow in memory, and then you have these proxies. So these proxies are just static overhead that you introduce. It also means lazy failing, exactly like before. So now you have your twig template, and you want a list of images, and for each image you want to see the size. And then suddenly one of the images is not on the drive, and you get an exception. What? I thought you loaded the image before. No, it is actually happening after, so that will probably cause exceptions in cases where you have failures. So you usually use this stuff only when the system is reliable on input-output operations. It is not the other problem, which is minor, is that our wrapped object is not actually the real. The proxy is not the same object as the wrapped object. The problem here is basically if you use a fluent interface, or if you pass the wrapped object to third-party APIs. Now you have two objects flying around. This is a minor problem, but it may be very confusing because some objects have the proxy, some objects have the real instance. And that depends on how you code the API. But basically, this is a problem that breaks identity. So you can't be sure that the proxy and the real subject will basically satisfy the identity operation. So equals, equals, equals. The other type of lazy loading proxy is the ghost object. So the idea is that we have an object, and all the properties of that object are exactly like the properties of the real object that we want to delegate execution to. So what we do is basically create this object, copy all the properties, and set them to null. And this basically means that every time that we access the object, we need to load all these properties if they are not yet set. So it is very useful when we don't need to, we want to not break the identity operation, which is why the ORM uses this kind of proxying and not the other type, because you don't know if the object is one of the other or the other. You just have one object now. And this is how doctrine proxies are generated. So you may look into the library and see how they do that. It's not that complex. But the idea is that we are really building something more complex. So I'm building a simplified example. Don't take it as a reference. It's just to give you the idea. So what we do is we have the image ghost proxy, extends an image, and we now have some more properties, for example, the initialized flag, which is false in this case. We construct the object again with the path, not with the real instance. And then what changes is that, first of all, the init method changes. So what we do in the init method is not building an image and setting it into a property, but what we do is copying all the properties of the image object into the local object. Okay? And then we set initialize to true. So it's a bit more hacky. This is actually very hacky because we're copying a protected property from one object to the other. So don't take this as a reference. And then what changes is that we're not in the getSize method, we're not delegating work to a second object, but we are just calling the parent object implementation. So that allows us to basically have a single object that does all the work that we need. This is very simplified. Don't take it, again, as a reference. So the pros and cons are basically the same of the virtual proxy. The idea is that we now have the same identity of the real subject. We don't have two objects in memory. We just have one object in memory. That is really relevant for some APIs. It keeps initialization logic away like the other implementation. It improves input-output operations. It doesn't have that much overhead. It is much harder to implement than the virtual proxy. There's a lot of code generation to be done if you do this correctly. If you do it manually, it is really easy to make it wrong, to build it wrong. So it may require reflection, it may require tricks with the closures and bind to. It is really tricky to use. Again, it is not useful when the data is already loaded and so on. So, and also, again, it will fail exactly like a virtual proxy. So you get the idea. They're not simple. There are a lot of magic, okay? Protection proxy. Protection proxy is the firewall that I was mentioning before. So the idea is that the protection proxy is there when we have an API, we built it, we built our code, and now what we want to do is protect it. So we want to avoid any kind of unauthorized access. So what we do is instead of coding all the ACL rules into our API, which may be a problem if we want to test it and so on, we keep two separate objects, and one is the wrapper around the other. So this is more like a decorator. But this is what we basically build. We have an API object, we extend it, and then in this case, I'm just limiting to a count of calls to the doStuff method. So we have this API object, we pass it in at construction time. We have a limit of calls that we want to enforce, and then we have a doStuff method, which will basically use the counter internally. So it will call the count method, and basically we're limiting the number of calls to this counter. And if we go over this limit, we basically throw an exception. And then we delegate the calls to the API object. So this is very simple. It's just a wrapper. It just limits access to our object. And this is how you use it. So basically, you build an API protection proxy around a real API instance. I don't know what the parameters of it are. And then you pass in a limit of 50, for example. And then you run an infinite loop, and you run API doStuff. And at the 51st, so after 50 iterations, it will basically throw an exception. So this is basically useful to limit any access to any API. We already coded it. We're not worrying about ACL. We're not coding about limiting access. We're really focusing first on our API, our implementation. And then we code this other object, which will just limit access to what we already built. So the problem is that it modifies how our object runs, because now we have exceptions bubbling up, and we didn't expect them. But since it is a security-related issue, we want to limit access, and we don't care about who calls it. It is not really a problem. So even if you throw an exception, it's their problem. You just wanted to stop access to some methods. And then there's the smart reference, which is the complexer type of proxy, in my opinion. It basically allows you to execute more operations as soon as something happens. So, for example, logging a DB connection, or adding event triggers whenever a method is called, and so on. So this is actually, again, a decorator, because stuff may change a lot depending on how you implement it. I think this is very good for AOP. How many here have been using the AOP bundles? Did you enjoy it, or was it more like a mess? It's okay. Okay, so AOP is kind of a black beast. It's really, really dark magic. It may be very useful in some cases when you try to debug stuff and so on. I personally don't like it that much, but it simplifies code a lot, especially if you introduce logging on some APIs and other stuff like that. You don't really want to code APIs specific to logging for that. You just really want to use a smart reference in those cases. So again, it is very useful when we want to cache execution of a method. So we have a method like a hash function, and that hash function may take 20 seconds to execute. And it will always have the same result for every input. So we want to cache that result without coding explicit caching logic into it. We may use it for logging, we may use it for event triggering. Whenever you send an email, also write it to disk. Whenever you register a new user, also send him an email, or send me an email. And it is useful for mocking. PHP unit mocks, PHP unit mock objects and mockery objects are basically these ones. They're just smart references. Every time that we call the mock, they count something, they verify that the parameters are correct, and so on. That's what these mocks do. They are smart reference types of proxies. And there's in general AOP. So a smart reference example. Let's make caching around an API of some type, and we're caching a really, really slow method. So I'm not going to write the entire proxy for this, but the idea is very simple. So we now have a stuff function or method, and we annotate it with some AOP cache with a time to leave of 3,600 seconds, which is an hour. So whenever we call this do have stuff, we basically want its result to be cached, and we don't care about who is building the cache and how that's going to be handled. So what internally happens, and this happens when you use the AOP bundles, is that these will basically build a proxy around it. So what they do is rewriting the API, and now they have an API caching proxy, extends this API object. I'm assuming it is the object that contains this do have stuff method. And what we do is changing the constructor again, and we're doing this in the dependency injection container somewhere. And whenever we call do have stuff, we do actually try to hit the cache. And if we have a hit, we just return it. Otherwise, we're going to delegate execution to the wrapped instance. And this is, again, kind of a decorator. And then we save the result into the cache with the time to leave of 3,600 seconds and return the result. So this is simple stuff, but if you introduce it in every object manually, it becomes really, really, really annoying. You got a lot of mocking to do, you got a lot of stuff that is going on in there, so you need to think about every possible case. And here we already have one conditional more. So it just adds more and more to your objects whenever you actually probably just want to code the API first and cache later. So this is one possible way of caching. Explicit caching is also a solution. But this is useful when you want to work with annotations or configuration. So let's go to the more complex stuff about this. So the idea is that we now know what these proxies are, and we have some families of proxies and things that they may solve. And what we want to do is implement a proxy. So what I see often is the poor coders proxy implementation, which is basically this. How many use PHP magic methods here? Just? Okay. I was expecting more. I mean, why do you use PHP? No, seriously. This call method is basically PHP magic. It will basically catch any call to the object, to any method. And in this case, what we're doing is it's just delegating the call and passing the parameters to some wrapped instance. And this is the poor coder's proxy implementation. And the problem is that this stuff, you should not do it. Don't do it. And why you should not do it. So the idea is that if you have a bank account object and you have a method pay, bank account pay with another bank account. So you want to pay to another bank account some amount of money. What the poor proxy does is getting some wrapped instance passed in and then calling whatever method it is called on the wrapped instance. So what happens is that as soon as we build the poor proxy around the bank account and then we say pay, oh sorry, pay is not a method, it's just a function. So whenever we say pay with the account, it will just explode. And that is very simple because our poor proxy is not a bank account, it's just a poor proxy. It's a separate instance. So the idea is that we are not respecting the list of substitution principle, we're not type safe, and therefore our system crashes. Implementing a generic proxy is a bit more complex. So you must respect the list of substitution principle, so otherwise Barbara Liskov will come and hunt you down. It is not so trivial. And also it is because PHP contains a lot of magic. So we have magic getters, magic setters, serialization, array access, cloning, whatever. There's a lot of broken stuff. Public properties. We wanted property accessors to get rid of getters and setters finally, but it didn't get accepted, sadly. So there's a lot of problems to consider whenever proxying an object. And this is what a proxy looks like when you generate it. And this is when, sorry, I can't find my mouse. Okay. So this is basically the implementation of a proxy for an object with one single method. So you see we're basically rewriting all the API just for one method, one object with one method. And this is really ugly. And you don't want to do this on your own. Actually, you should not do it on your own. So what I did is writing a library called Proxy Manager, which started as a troll project. I wrote it for a conference, and then I wrote it just because I wanted to see how far I could go with this stuff, not because you should always use it. But it became pretty stable. And what it does is handling all this ugly code generation that you saw to build virtual proxies, smart references, ghost objects, null objects, which are another family of proxies. If somebody has questions on that, we can see that later. Remote objects, and so on and so forth. So basically, it solves the problem of generating all this crap for you. So this is how you use this stuff. Please excuse me for the naming conventions, but we'll see that. So we now have a very slow object. I'm building on purpose a very slow object. This object takes 10 seconds, blocking seconds to instantiate for some reason. I'm just putting a sleep there, but what could happen is that we're trying to build an ORM. We are injecting a very complex object. We are loading some files, whatever it is. So what we do is then we have a do-foo method, and this foo method in this case just echoes something. We don't care. But the idea is that it is really, really, really slow to instantiate. What we do is having some kind of crazy factory. So as you can see, I'm not good at naming conventions. This is a lazy loading value holder factory, which is kind of like the what we say that is bad in Java, which is I think in Spring, or it is the abstract singleton proxy factory or something like that. But I'm getting near to that. I'm working hard to get their naming conventions also in my code. So this factory is basically instantiating a my-slow-foo object, and this is what it looks like. So basically I'm saying there's a wrapped object parameter, there's a proxy parameter, and then I'm just saying, okay, every time that you call any method on this proxy, please call this initializer. And this initializer will basically fill in the wrapped instance and then set the proxy as initialized. And then every time that I call this do-foo method, I will basically have the do-foo method executed on a real instance, but this method actually returns immediately. This instantiation logic returns immediately. So I can build thousands of these very slow objects within milliseconds, depending on how fast, obviously, your machine is. But the idea is that we don't have these 10 seconds to wait. We can just instantiate them. And as soon as we call some API on it, proxy do foo, we then have to wait 10 seconds. We have smart references. And again, it is always the idea of using some ugly named factory. This time it is an access interceptor value holder factory. We're gonna have jokes on this soon, I think. But the idea is very simple. We're building some kind of factory. Forget the name, alias it, call it whatever you want. And then we're saying, okay, give me some proxy. And I want the proxy around the DB connection. Every time you run a query, then please echo query is being executed. And after this query has been completed, then call query completed. So every time that I now have this DB query method call, I will have an echo before and an echo after. That's really useful if we want to do logging without knowing how the object we have to deal with was implemented. So we have some implementation in Symfony, in Framework, in typo3, whatever, and we want to proxy it. We don't have to code or keep backwards compatibility with them. We just have some factory, and it uses some reflection magic, and it tries to abstract that object into a proxy. And if it can't, it will just throw an exception, but that should not happen because I'm working on this stuff to make it work, actually. But the idea is very simple. You don't have to code this stuff by hand. And yes, I'm not good at naming classes. So if anybody has good suggestions for me, just send me an email or something, because I'm pretty much desperate on naming. This stuff integrates actually with Symfony, so that's maybe why they invited me to talk here, because I snooked the proxy stuff into Symfony like 6 months ago or something. And the idea is basically that when you have, like, for example, the dependency injection container, and you want to instantiate the security container, security components, which have a lot of dependencies and voters and so on and so forth. You have dozens of objects being instantiated by the dependency injection container, and you may not even use them because you short circuit and you exit the application before because something actually skips security for some reason. So what you do is basically say, we want to avoid instantiating all this stuff because you're not going to use it, so proxy it. Make it lazy. Instantiate it only when we need it. So this is how it works with Zen Framework. We just have some dependency injection definition. We just say that my service name is handled by the lazy service factory, and then we basically have to tell him also what class is used. So this is how you use it in that version, and this is how you use it in Symfony. So we have my service name, which is a my service class name, and then you say lazy true, because we implemented just the lazy version of proxies here. And this will basically make that object lazy. You now can basically define every service in your dependency injection container as lazy. And if that object takes a lot of time to instantiate and you're not using it all the time, you can use this logic to avoid that overhead. This is interesting if you have very complex applications. And just to have it working, you just have to require the proxy manager. We did a Symfony project and it works out of the box. So Symfony will basically just check if the proxy manager exists. It is not like you need to install some configuration or something. So there's some useful libraries that I used to build this proxy manager and to gather all the contents for this presentation and all the swearing against stuff that doesn't work and so on. So there's the doctrine proxy generator, which is the most usual one. It is very simple to read. It is just a very big class with a lot of template code in it, so you can really see how a proxy looks like when you cover almost all the cases. We have proxy manager, so check it out. Otherwise, I'll find you and I'll kill you. We have flow, typo 3. What they did is very smart. I'm not really sure that I like it, but it is really interesting. What they do is basically dependency injection via proxies. So if you mark a property of an object as @inject something, what they do is basically rewrite the entire class so that whenever it is constructed, the properties get filled with the values from the dependency injection container. That is property injection. It is considered a bad idea. Don't do it. But it is still cool engineering porn. It is really interesting for me at last. And then there's the CG library by Johannes Schmidt, JMS, for those who use his bundles. And this was basically where I started off building my stuff, but then I could not use it because of licensing issues. And then I consider looking into Alexander Lysashenko's work. He is working on the Go AOP Go AOP PHP library. And what he does is basically using proxies for AOP. So if you're not familiar with AOP, I'm not telling you use AOP because you must really have a good reason to use AOP. But check it out. And what he does is really, really, really tricky. So what he does is whenever you autoload a class, he replaces the entire autoloader of your application. And whenever you hit the file while autoloading, it rewrites the entire file with a proxy. So that is really like, what the heck is going on here? That is really complex, but it is really interesting to see. So check it out. Before we get to the dirty stuff, are there any questions? No. Cool. Awesome. Okay. Now I'm just going to skip to trivia stuff. So proxying fluent interfaces. Want to show a trick about how to proxy fluent interfaces. I just included this as a parenthesis because I had very many problems with fluent interfaces because they break virtual proxies, protection proxies, smart references. Fluent interfaces are really breaking everything. They're really bad. Don't use them if you can. Actually, anybody who likes the fluent interfaces? Is there anybody here who actually loves fluent interface? Get out. Now. No, seriously. Okay, and they break encapsulation because you basically have some object closed into an object, closed in another object, and you call a method and you get this super wrapped object somewhere. It's not just a problem with proxies. I wrote an article on that, so maybe check it out. So what we have is a bank account, and we have a bank account with a protected amount of money. And whenever we say pay, we basically decrease the amount in the bank account. So this bank account, as it is designed right now, is always on loss, which is basically everybody's bank account. So what we do is we have this happening. So every time that we pay, we reduce the amount in the bank account. So what I'm going to show is just a dirty hack. So don't use it at home if you don't need it. It's not about proxies. It's in general just a trick on how to build wrappers. So what we do is, in order to keep fluent interfaces working, is we extend the object, this bank account, and at construction time, we get a real bank account passed in, and we copy all of its properties, all of its private and protected properties. And then basically this works with fluent interfaces. So this will now work. And public properties proxying without property accessors. I just need to skip over this because we basically have no time anymore. So we have a customer object with a public name, public surname, and we want to track access to these public properties. And this is again a dirty hack, so don't do it at home. So this is what we do, is unsetting the private and protected properties. And then whenever we basically try to access these properties, what happens is that the magic getter and magic setter will be invoked. And that's because basically of how PHP works internally. So don't do this at home. If you do this stuff at home, you get punished. Punishment for this is some, what does it say? It will be dealt with in the most severe manner, involving chicken feathers, cod liver oil, and a very, very depraved walrus. So be careful about it. Thank you. Check it out on GitHub and ping me there. And if you got any questions, we don't have any more time. So catch me around. Thank you.